Okay, great. Let's get started. How to write complex data pipeline in Ruby. Let's welcome Mr. Honda.
Hi everyone. Did you have a good lunch? Yes. Yeah. Oh, that's good. Okay. So let's listen my session. Yes. So let's start my session. Okay. Today I'm talking about how to write complex data pipeline in Ruby. Let me introduce myself. My name is Kazuyuki Honda, and DevOps engineer at Quipper. My nickname is Hakobera, so you can find me at Hakobera on GitHub and both GitHub and Twitter. Quipper is an edtech company. Our services is launched in 6 countries, Indonesia, Philippines, Mexico, and Japan. And I'm struck the data from the students and teachers. So today's session is data about Quipper. Okay, so I explain about what data pipeline in this session. Here is a data pipeline. Data pipeline is a sequence of data and tasks. Rectangle is a data and circle is a task. Okay, data pipeline is represented as dark directed cyclic graph, and it's important point with no cyclic dependencies. So data flows only one way in this diagram, the side left to right only. So tasks can read data which generated by previous tasks. In this diagram, task 3 can read the data generated by task 1 and task 2. But task 1 cannot read the data generated by task 3 because the DAG has no cyclic dependencies. So this is the data pipeline. Maybe someone calls this as a job flow or job net or workflow. Okay, you can see this data pipeline in somewhere. For example, ETL process is one of the data pipeline. Extract production database, transform cleaning, and load it into the report database. Or another example, generate report using SQL which has dependencies. For example, we are having the access log and summarize the access count per user by SQL and save it into the summarized table. And then join the summarized table with user master table. So, and we can finally get the report, access report per user. This is SQL with dependencies. In our situation, we are collecting many data all data into Google BigQuery. Our Ruby application generates some event data or access log or some master data in our production database. And we are using the BigQuery as our analytics platform. So analysts use the Redash as the data as a dashboard tool and generate a report in Google Drive or BigQuery itself and decide what to do next. So in this section, in this diagram, data pipeline is here, ETL process, and this BigQuery is summarized query sequence. Okay, next, I explain about how much data does Quipper processes. Okay, here's some figures. Okay, this is per day activity. Currently, we are collecting the 100 gigabyte events and logs per BigQuery and scans 4 terabytes per day, and over 40,000 queries are executed here. Okay, so this is not so big. Yeah, there are many big companies in the world, but I think that figures are not so small. So we have to consider about how to write complex data pipeline more easy and run it stable to drive our business. So we have to write the data pipeline to analysis, but in some reasons, writing data pipeline is not so easy. So why writing complex data pipeline so difficult? Because we have to consider many things not directly related to data and tasks, such as dependency resolution, error handling, idempotence, retry, logging, or parallel execution. This feature is very important to implement the data pipeline, but this not includes the logic we want to write. Okay, let me explain about this in sample code. Okay, this is very simple data pipeline. 2 tasks and 2 data. Okay, first, task is just something we want to process the data. So in this case, define the method as the task. And this is a sequential task. So write this call to task 1, then do task 2. Ruby execute this method as sequential. So in this case, this dependency resolution is resolved. Okay, next, the error handling. Surround all the editing and let's debug. Then implement idempotence. Idempotence is a little bit difficult. It's a mathematical concept, and in other words, idempotence is we have to get the same result anytime we run the data pipeline. So, for example, we have to see if the data already exists. So, this line, unless data exists or unless data exists, I check the code. And okay, then add the logging to trace the state of the workflow. This is a trace log. Okay, so last we have to implement the retry logic. Okay, we can use a retry algorithm like this also. This is and all requirements not related to the logic is implemented. Okay, but you see, and this is too many boilerplate code. This do task 1 and do task 2 is logic we have to implement, but other codes are not related to our real requirements, but it's needed. Too many boilerplate code. So to avoid this boilerplate code, we need a solution. So, but this situation is a very common problem in engineering. So there are already resolved by software called workflow engine. Workflow engine can resolve this problem. So, and there are already famous open source workflow engines available. For example, Reach developed by the Spotify, or Airflow developed by the Airbnb. Airbnb is now become, Airflow is now become Apache Incubator. So, okay, this software is developed by the large size company, and this is very awesome software. But they have one important problem. They are written for Python, so not for Ruby. Okay, yeah. I think you want to write a data pipeline in Ruby, not Python. So I made it myself. So this writing in data pipeline, we can, if we can write the data pipeline in Ruby, we can use our application code, especially active record model. So it's useful for Ruby company to enable data pipeline in Ruby. So I made it and named gem Humidity. Humidity is an open source plugin-based Ruby library to build, run, and manage complex workflows. What features Tsubuki provided is like this, define workflow using internal DSL. This is very important point. We can define the workflow, it means a data pipeline using Ruby code. So we can version control by Git or GitHub, and so easy to integrate the current CI or CD flow. And some of the tasks resolve the problem I previously explained. Task dependency resolution, error handling and retry, support build idempotent data pipeline, and centralized logging, and parallel task execution using threads, and visualize data pipeline, and plugin architecture. Plugin architecture is a unique point of Tsubuki, so I explain it later. Okay. I explain about what Tsubuki does not provide. Tsubuki is a not full stack workflow engine, which Tsubuki has not full features which other workflow engine has, such as scheduler, event trigger. So use external tools like Chrome and Jenkins. And Tsubuki can also does not provide an executor for multiple machines, so you cannot distribute. So one data pipeline can only in one machine, because Tsubuki is just a CLI tool. So this is a very important design concept of Tsubuki. Tsubuki is mainly I developed Tsubuki mainly for Google BigQuery. So Tsubuki is a workflow engine, but just like a control cloud services, for example, BigQuery or cloud storage. So there is no need to full stack distributed executor. But this is cheap, but you can sync multiple data pipeline using the external task, so, which is bundled by the Tsubuki. So if you want to sync the multiple data pipeline in different machines, you can use this technique. Okay, so let's write the data pipeline with Tsubuki. Okay, this diagram again. So let's write a data pipeline with Tsubuki like this. Okay, this is a Tsubuki DSL, and This is like define the task and output, and run is the logic you want to do with the data. This is very clearly to write the data pipeline of this. Has two tasks and two outputs, and defines a dependency with requires method. Okay, see before and after. Before code, I previously explained with many boilerplate code, and this right side is this pipeline with Tsumugi. So it's very clear to define tasks and data and logic. Okay. Above diagram is what do I implemented, and below the code is code. It describes this data pipeline. Okay, this is the basic of the so next, I explain how do I abstract the data pipeline in Ruby. Tsumugi has three main components: task and target and parameter. Okay, I explain each. So first, task. Task is task is represent task in data pipeline, and this is the main part of the data pipeline. Write your own data process logic in run method. Run method is like in this described in here. So the input to data, you can read the input data in run method and generate the output data in run method. Next, as predicted, what Kazuyuki describes task dependencies. Task also has a requires method which writes dependency of task. The requires requires method information is used by Tsumugi to build the internal in the Tsumugi. So Tsumugi pass the DSL and pick up the required information and internally build a DAG in memory. So this code again, you can see the run method to implement what you generate the output data. Task 1 only generates the data using output, and task 2 dependencies dependent by task 1, so task 2 requires task 1. So Tsumugi wait to run task 2 until task 1 is finished. So task 1 is finished, Tsumugi runs task 2. And task 2 can read the output data generated by task 1, so by method input. This input method is returns data task 1 generated. So this output data is target. So I explain about target in next term. So you can write not only the single dependency, you can write multiple task requires like this. So in this case, so last task requires second task and another second task. So internally, it's maybe build a DAG like this. Next is target. Target is abstract data in data pipeline. For example, local file, a remote object in the storage or database table, etc. So target must implement exist method. For example, this code represents a local file target. Target must inherit target class and implement exist method. So this is the local file target. So exist method returns the result of the file exist for specified path. Okay, you can implement the exist in your application requirement. So you can write not only the existence of the file, you can write the content, internal content of the file. So you can write, for example, file exists and file contains at least one row. If a file is empty, you can write return false in exist. So if file exists but it's empty, so this target return false. So return false. So this result of the exist is internally used by Tsumugi. This is the thread code of internal of Tsumugi executor. Tsumugi executor execute tasks defined in the DSL, so in loop. So until all tasks in DAG complete, get the next task, and if task output exists here, this is a red rectangle here. So if task already exists, task run method not called, so just skip and call the next task. So task exists method helps to build the idempotent data pipeline in Tsumugi. Okay, so target is sorry. Okay, again. So target is instance to access the data, to share the data between tasks. So output target data 1. This is generated by task 1, and in this case, input task 2 input and task 1 output is the same instance. So you can read you can share data between connected tasks by output by a task's input data. Okay, so next I explain the last component, parameter. Parameter is another input data of task. You can read parameter in task and learn method. Parameter is important for the programming architecture. So you can define the parameter using parameter. This is, you can define any name in tasks and you can set the default value. You can read parameter in learn method like this. And you can, this is important, you can override the parameter value which defined by the plugin. So you can write code. This is like code key2 is set key2 to this value in like in DSL. So they run this pipeline with Tsumugi. Put S key2 shows another parameter. Parameter also provides a feature which binds bar from the CLI parameter. So CLI option, if you want to set column 1 from the CLI option, you set outline true of the option to true and pass the parameter like this key column value. So you will run this data pipeline. You can see the hello. Okay, so this is the 3 main components. And last, I will explain about the plugin architecture. Okay, actually, Tsumugi's task and target is everything is plugin, which is everything. So bundled task and target is also plugin. You can raise the plugin like plugin data task name and class. So you can refer the task by DSL type. This is type. Register and use it. So you don't explicitly require this class. Tsumugi automatically resolves the dependency and automatically requires the task plugin it's defined. Same as the task, target can raise the method you can use plugin based the target also. So you can use it in DSL without explicitly required. So this for this mechanism, so you can find and raise Tsumugi plugin in Ruby gems. So you can, if you write your own Tsumugi plugin, you can distribute the Tsumugi plugin from the Ruby gems. For example, this is a plugin I write. This Tsumugi plugin BigQuery is integrated Tsumugi with BigQuery, and Tsumugi plugin command is through plugin to integrate integrate the shell. So, okay, at last, I show you a real world example Tsumugi. Okay, I show you, in our case, we are using the ETL process with using Tsumugi. We export the multiple MongoDB person using Embark, and so we are using the dynamic workflow. Dynamic workflow is, so Tsumugi DSL is just a Ruby code, so you can use, you can write everything, you can do anything what Ruby can do. So this is an example. For example, this is the schema files in some directory and requires and using a map method. So and define the task with loop. So if you want to add another table, just put the schema file in schema directory. So you don't have to modify your code. This is a very useful example. Okay, so last one is I want to demo. Okay, this. Yeah, this is a very simple example. Okay, so and show you the visualization feature of Tsumugi. This is using the graph base to describe, visualize this task, and this is a cell and generate and visualize. Okay, so next, I explain the. I show you the. Okay. Okay, this is a real-world example. Export BigQuery result to the Google Drive and notify UI. UI. UI 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 SQL like this and store it to the Ruby query and after finish the okay, we can get the notification from the Slack, and you can click here and you can now you see the result and of the query to the Google query is called. This is a real world case of our situation. Okay, so that's all. Thank you. Any questions? If we have time.
We still have 3 minutes, so we're open for 2 questions.
Here.
Thank you very much. Just a quick question. Maybe I missed something, but what was wrong with break?
What?
What was wrong with break?
Oh, yeah, wait. Sorry. Okay.
Break.
Right.
Luck? Oh.
You guys are Japanese, you can just talk.
Oh. なぜ英語を使わないかっていう話。Yeah, okay. I tried to use Lake and previously developed Tsumugi. Yeah, Lake has features something like diminished resolution, but in the history, I'm trying to using the Luigi before the developed the Tsumugi. So, and I very like the concept of the Luigi, but it's Python, so I can write the Python, but my colleague cannot write Python, so it's hard to maintenance in work. So, okay, so I like the Luigi, but it's Python. Okay, I developed the Python Luigi like the workflow engine, so we can write the code with colleagues. So and Tsumugi is easy to rewrite the code from the Luigi. So, but Lake it's not so easy. So this is why I don't like. I did not use the Lake and develop Tsumugi.
Any more questions?
Any more questions?
Any more questions? No? No? If you have any more questions, please feel free to ask us after this section. Okay, great. Thank you very much.
Okay, thank you.